Okay, so we're going to go ahead and get started. This one is going to be number 27 in your textbook on page 161. And it says calculate how many moles of nitrogen dioxide, okay, form when each quantity of the reactants completely react. And so they have given us a formula. It is already balanced. We know that because it has the coefficients. And this one is an A through D problem. And so I'm probably going to work two of them. Let's do the mole problem, and then let's do D. Let's do a kilogram problem. So we'll do that. So we'll do A and D together, A and D. So we're going to start off with when we're given 2.5 moles of dinitrogen pentoxide. So that was 2.5 moles Okay, so here's our problem. So we are wanting, again, go back to the question. It says, the question is, I'll put it out here. The question is how many, excuse me. The question says how many, where am I at? How many moles of nitrogen dioxide are formed? Okay, so that's what my question is. So I'm going to moles. I'm starting with moles. And so again, first question, always ask yourself, is the equation balanced? And again, we said yes, it was. Then, do I need to know my mass? And no, I don't, because I'm just doing a mole to mole conversion. Again, the next thing that I would do is I would come in and kind of do a highlight of some kind. I am starting here. Okay, I'm using this one, and I'm going to nitrogen dioxide here. So those are the two that I'm working with. Okay, now whether you go ahead and write out your mole conversion, that's up to you, but I would definitely highlight it or write it out, one or the other, or both. It doesn't matter to me. So we're going to write down our given. I am doing a mole to mole conversion. I need my moles of N2O5, and again, you could start off and just write those down in O2. So I've got my two that I need. Here's my two that I need, and then come back up here and look. Just double check. This is a 4. This is a 2. Now you are welcome at that point, if you want to go ahead and do a 2 to 1. I would probably put the 4 to 2 down and then do your 2 to 1. But I've already got it in moles. So I'm going to do my unit cancellation. And the rest is calculation. So if I reduced here already, I don't need to even worry about my denominator. So it's 2 times 2.5, which is 5. Now, be careful again, because I need 2 significant digits. So even though 2 times 2.5 is 5, I do need to hang on to that 0 for significance. Moles of NO2. Okay, and there's my final answer. So moles to mole conversions, actually very easy. So then the next one we said we're going to do is D, and it's 2.87 kilograms of N2O5. Now the question still asks for, it didn't change the question. The question is still moles of NO2 formed. Okay, so the question didn't change. Now I might rewrite the formula up here, or definitely go back in and look to see, no, I didn't. So I'm still using the same 2. So that piece didn't change either. So I know I'm going to use the same mole ratio. Okay, now what's different here? So yeah, we've got kilograms. So we know we don't want kilograms. So we're going to need to take kilograms and change it to grams, right? So what is the conversion from kilograms to grams? Okay, so yes, there are 1,000 grams in 1 kilogram. So be sure you get the 1 to the kilograms, 1,000 on the grams. So that's going to be our first step. So let's go ahead and write that down. 2.87 kilograms of N2O5. And I know that 1 kilogram of N2O5 is 1,000 grams of N2O5. So change, convert, cancel it out. Okay, now I've got my grams. I'm eventually going to need to get to moles of the nitrogen dioxide. So what do I need to know next as a step? Okay, so hopefully you saw that you need to do a gram to mole conversion of the dinitrogen pentoxide. So calculate out the mass of dinitrogen pentoxide. Okay, so I got 108.01. Again, cancel out. I'm now down to my moles of the dinitrogen pentoxide, but I need moles of the nitrogen dioxide. So what should be my next step? And hopefully you said the mole ratio now. So moles of dinitrogen pentoxide, moles of NO2. Okay, again, it was a 4-to-2 or 2-to-1. Okay, and there's all my steps. And so when I look at this again, I'm wanting to know how many moles were formed. Here's the moles that are formed on that. So I've got everything canceled out. The rest, as they say, is calculations. So go ahead and run your calculations and see if we agree. Okay, so let's see if we're in agreement. So when I multiplied my numerators, I got 11,480. My denominators, I got 216.02. I divided out and I got actually 53.1432, blah, blah, blah. But significant digit wise, I only needed 3 in this case. So 3 here. Okay, now I will make just a quick comment for some of you possibly that watch this who are like, okay, did I need to put this conversion in? You know, I'd like for it to be in for sure, but you know, earlier on when we did metric conversions, we learned to just move the decimal right or left. The only thing I'm going to tell you is to be very careful with that, especially as we get later on where we're doing volume conversions or even area conversions, if we're doing pressure or volume, maybe the gas laws, some of that kind of stuff, because then you might mess yourself up. So, you know, that's kind of a call on that. I would like for you to put it in, but would not necessarily count it wrong, but I would need to see over to the side somewhere here that you moved your decimal and then wrote it as 2870 grams. Okay, kind of show me that to the side would be great. Okay, very good. So that again is one, a mole to mole conversion, and then this one was a mass or a gram to mole conversion. So still just a slight less than a gram to gram conversion on that.